distance will be 1. So that Hamming distance, if the Hamming distance is 1, so then it can be said that single bit error words. Single bit error words. Why this is single bit error? Because this is 0, 0, 0. I'm bothering about 0, 0, 0 and 1, 1, 1. Okay. So this is the Hamming space. So in the Hamming space, there is 8 words, 8 possible words. And from the 8 possible words, I'm taking single bit error words. Okay. Why this is called single bit error words? Because when I'm considering 0, 0, 0 and I'm taking these examples 0, 0, 1, 0, 0, 1, 0, 1, 0 and 1, 0, 0, you can see that for each Hamming distance, you know that when I'm calculating 0, 0, the Hamming distance between 0, 0, 0 and 0, 0, 1, the Hamming distance is 1. For this also 1, for this is also 1, the Hamming distance is 1 between 0, 0, 0 and 0, 0, 1. Hamming distance is also 1 for 0, 0, 0 and 0, 1, 0. So in this way, for 1, 0, 0, Hamming distance is also 1 between 0, 0, 0 and 1, 0. Okay. That means if I change only one bit, if I flip only one bit from these codes, we can get the original code. So that's why this is single bit error codes. That means if 0, 0, 1 is there, so if I change this 1 to 0, so we will get 0, 0, 0. From the second code sequence 0, 1, 0, at the second position, if this 1 is changed to 0, 0, if this 1 is changed to 0 or flipped to 0, we will get the 0, 0, 0. So this is basically the 1 bit error words. Okay. So the Hamming distance is 1. Okay. So we have to consider again the 1, 1, 1 sequence, because I'm taking 2 code word as 0, 0, 0 and 1, 1, 1, and I'm calculating the error correcting code. Okay, error correcting code. So calculating single bit error words respect to 0, 0, 0, we get this, the Hamming distances is 1. Okay. Now next, calculating single bit error words respect to 1, 1, 1. From the Hamming space, if I choose these 3 code words, then if the Hamming distance is calculated with respect to this 1, 1, 1, then again we will see that this is also single bit error, because you can see that if I consider this is 1, 1, 1 and this is 1, 1, 0, so Hamming distance is 1. Again for 1, 0, 1, if I calculating the Hamming distance with respect to 1, 1, 1, the Hamming distance is 1. Again this is also 1 and this is also 1. So again we can say that if this 0 is flipped to 1, then we will get this original value. This is 1, 1, 1. If at the second position this 0 is flipped to 1, then we will get 1, 1, 1. At the first position this 0 is flipped to 1, then we will get 1, 1, 1. So in this way we can say that this is also the single bit error words respect to 0, 0. So again we are getting Hamming distance as 1. Okay. So calculating Hamming distance respect to 0, 0, 0, calculating Hamming distance respect to 1, 1, 1, we are getting Hamming distance as 1. Okay. For the both cases. Okay. So as I've told you that calculating the single bit error with respect to 0, 0, 0, we have chosen these 3 bit sequences from the Hamming space, and we have got the Hamming distances as 1. And from this, considering the 1, 1, 1, we have already taken the Hamming distances as 1. Okay. So for both cases of 0, 0, 0 and 1, 1, 1, one error correcting, mind it, one error correcting, that is k equals to 1, and Hamming distance we have got, this is 3, because when I'm calculating 0, 0, 0 and 1, 1, 1, okay, The Hamming distance between this 0, 0, 0 and 1, 1, 1 is 3, and one error correcting, that means k equals to 1. Okay, so between 0, 0, 0 and 1, 1, 1, Hamming distance equals to minimum Hamming distance equals to 3, and one error correcting code, that means we have considered k equals to 1, as you have seen, as you can see that we have considered one, that means single bit error code, single bit error words with respect to 0, 0, 0, and single bit error words with respect to 1, 1, 1. That means the k value is 1. That means if I flip only one bit, one bit, then we will get the original bit sequence 0, 0, 0. From this also, if I flip only one bit, we can get the original 1, 1, 1. So that's why this is called one bit error correcting. That means k equals to 1, and Hamming distance of 0, 0, 0 and 1, 1, 1 is 3. So that's why this is satisfying that this condition of the error correcting code, that is, which satisfy 2k plus 1 equals to 3. That means when the k equals to 1 and Hamming distance equals to 3. So we have told you that from the definition for the detecting purpose, the minimum Hamming distance will be equal to k plus 1, where k is the detected errors. Okay, so when I'm considering the k error correcting, that means we have to correct only k number of bit. Okay, so here from this example we have to correct only one bit, because this is single bit error. So you have to correct one bit only. So k equals to 1, and that will be equal to, for the correcting code, there is that means k error correcting code, the minimum distance will be equal to 2k plus 1. So that is basically, you have seen that here it is satisfied that 2k plus 1 equals to 3, because the Hamming distance equals to 3 and 2k plus 1 is also 3. So this is the relation between the k correcting code and the minimum Hamming distance. Okay, and this is the relation, there is this k plus 1, this is the relation between minimum Hamming distance and the k error detecting code. Okay, so k error detecting and minimum Hamming distance, the relation is k plus 1. That means k plus 1 will be the minimum Hamming distance, where k is the number of detected errors, and here for k error correcting code, 2k plus 1 will be the minimum Hamming distance, where k signifies the number of error you have to correct, right? So this is satisfying this condition. That means 2k plus 1 equals to 3 for this example, and this whole thing is called the Hamming sphere. Okay, this whole thing is called the Hamming sphere. That means this error correcting, that means k error correcting code is also called the Hamming sphere. And next it is written that there's a code word with minimum Hamming distance, that is d. The code word with the minimum Hamming distance, that is d, between its code word can detect at most d minus 1 errors and can correct d minus 1 by 2 errors. So d minus 1 by 2 is called the error correcting capability of the code. That is, relation between Hamming distance and the error correcting capability equals to d minus 1 by 2. So that is the relation. Okay, d is the distance, d is the Hamming distance, so minimum Hamming distance. So you can say the relation between minimum Hamming distance and the error correcting code, or you can say the error correcting capability, equals to d minus 1 by 2. That means error correcting capability equals to d minus 1 by 2, where d signifies the Hamming distance, the minimum Hamming distance. So that is the note, and there is the answer to this question. It's very important question, so you can follow. The video is up to this. Thank you.